The year is 1940, and the German Wehrmacht is redefining warfare with a ruthless, rapid advance. Their blitzkrieg strategy tears through Europe, demonstrating a decisive superiority in armored maneuver and combined arms. German tank divisions, spearheaded by the Panzer IV, move with a speed and coordination the world has never witnessed. The High Command, confident in their mechanized doctrine, views all Allied equipment with a mixture of disdain and professional pity. German generals, educated in the rigid philosophies of war, scoffed at any Allied attempt to modernize or mechanize their own forces. They saw the future of artillery as either immense towed guns for static siege warfare or high-velocity guns mounted on their own formidable tanks. The concept of a dedicated, mobile, self-propelled artillery piece for the common infantry division seemed redundant and inefficient to their minds. They believed that their tank destroyers and armored cars could fulfill any necessary mobile fire support role with greater efficacy and better armor protection. Reports filtering back from the early desert campaigns began to mention an American machine, a squat, open-topped vehicle firing a large-caliber howitzer. These early reports were often dismissed in the German war rooms as descriptions of a hastily converted, poorly armored stopgap design. Field Marshal Erwin Rommel, the Desert Fox, was initially more focused on the heavier American tanks and their immediate anti-tank threat. The idea of a thin-skinned, self-propelled gun causing any serious tactical trouble was simply not given priority at the operational level. They judged the American approach to be clumsy, over-engineered, and lacking the elegant, focused specialization of their own purpose-built machines. This arrogance, born from crushing early victories, would ultimately blind them to the true potential of the new American workhorse. The German belief in their own technical and doctrinal superiority was absolute, a critical flaw that allowed the M7 Priest to arrive on the battlefield without the proper respect it deserved. They failed to appreciate the sheer volume of reliable American-made equipment that could be fielded against their increasingly strained logistics. The dismissal was not technical but philosophical, a fundamental underestimation of how flexible firepower could disrupt their rigid, overwhelming counterattack formations. The generals saw only a converted tank chassis. They failed to see the mobile fire base that would soon rain down destruction upon their own advancing troops. Their initial scorn was a direct consequence of their own successful, but narrow, view of modern combined arms warfare. The Priest was an anomaly in their world view, a machine they could not categorize as a tank or a dedicated anti-tank weapon, and therefore they dismissed its inherent threat. This dismissal provided the American and British forces with a significant, though silent, tactical advantage in the initial stages of its deployment. The United States military entered the war with a profound and immediate need for artillery modernization. Traditional towed artillery, while powerful, proved desperately slow to move and even slower to deploy once under fire. The devastating lessons learned from the static trench warfare of World War I were finally being fully applied to the mobile battlefields of the new conflict. American doctrine emphasized the rapid advance of armored formations, and the supporting fire needed to keep pace with these new tank thrusts. Towed howitzers often lagged miles behind the fast-moving tanks and infantry, leaving the frontline troops vulnerable to immediate enemy counterresponse. The U.S. Army Ordnance Department recognized that a self-propelled solution was essential to maintain the momentum of the offense. This new vehicle needed to be reliable, easy to manufacture in massive numbers, and capable of firing the standard, highly effective 105mm shell. The massive American industrial base, already gearing up for full-scale wartime production, provided the perfect environment for this rapid development. Designers turned to the already successful M3 Lee medium tank chassis as a readily available and robust platform. The M3's reliable engine and suspension system could handle the weight of the new armament and endure the harsh conditions of overseas deployment. By mounting the M2 105mm howitzer onto the M3 chassis, engineers created a vehicle that could move at the same speed as the accompanying armor. This combination ensured that the fire support could literally travel with the tanks, ready to lay down a protective barrage instantly. The vehicle was officially designated as the 105mm howitzer motor carriage M7, but its unique features soon earned it a more evocative nickname. The distinctive, raised machine gun ring in the front compartment, designed for anti-aircraft and local defense, resembled a Christian church's pulpit. British forces, the first to widely field the vehicle, quickly began calling it the Priest, a name that would stick for the rest of its long service life. The Priest was a marvel of pragmatic wartime engineering, prioritizing function and mass production over specialized features. Its open-top design, a characteristic that drew initial German ridicule, made it lighter, faster to crew, and easier to operate in the field. The open top also offered exceptional visibility for the crew and allowed for the quick reloading of the powerful howitzer. The development of the M7 Priest was a direct, no-nonsense answer to a critical battlefield requirement for mobile, indirect fire support. The formal requirements for the new self-propelled howitzer were finalized in early 1941, coinciding with the growing threat of a global conflict. Engineers quickly developed the pilot model, which demonstrated the feasibility of mounting the powerful 105mm howitzer onto a medium tank chassis. The primary gun chosen was the reliable M2 105mm howitzer, a piece of ordnance well known for its high explosive destructive power. This howitzer was a compromise, offering a good balance between range, shell weight, and the amount of propellant charge required. Crucially, the 105mm shell was capable of delivering a significant payload, which was essential for suppressing enemy positions and infantry concentrations. The initial M7 design inherited much of the M3 Lee's proven engine and track configuration, simplifying maintenance and spare parts supply immensely. Standardization of components was a key American philosophy, ensuring that vehicles could be kept running in the harsh and distant theaters of war. The fighting compartment of the M7 was radically different from the M3 tank, featuring an open-air enclosure to accommodate the massive recoil of the howitzer. This open design allowed for a much lower profile than a fully enclosed turret would have permitted, offering a smaller target profile. The howitzer was mounted to the right of the center line, a necessary placement to balance the weight and provide the crew with working space. A ready rack for 24 rounds of ammunition was cleverly integrated into the floor and side walls of the fighting compartment. This onboard storage meant the M7 could immediately enter action without waiting for a separate support vehicle to arrive with the necessary shells. The iconic pulpit for the .50 caliber Browning machine gun was installed to give the crew protection against low-flying aircraft and nearby infantry assaults. Production began in earnest in April 1942 at the massive American Locomotive Company, marking a significant milestone in military vehicle output. The speed of the M7's development and subsequent mass production was a testament to the efficient industrial capacity of the United States. Over 4,000 M7 Priests would eventually roll off the assembly lines, a staggering number that ensured its presence on every major front. The vehicle was a powerful statement of American logistical strength, designed to be simple, effective, and available in overwhelming quantity. Its reliability and cross-country mobility made it an instant favorite among the artillery crews who were tasked with operating it. The Priest's birth signaled a new era where fire support was no longer tethered to fixed positions but could move dynamically with the main assault force. The M7 Priest's operational debut came not with American forces, but with the British Eighth Army in the harsh deserts of North Africa. The initial consignment of M7s arrived just in time for the critical Second Battle of El Alamein in October 1942. This battle was a turning point, where Field Marshal Montgomery's forces would finally push back Rommel's formidable Afrika Korps. The British had struggled with the logistics of towed artillery across the shifting desert sands, finding their mobility severely limited. The tracked M7 Priest immediately solved this problem, proving its remarkable cross-country mobility and speed. In the open desert, the Priest could rapidly change position after firing, a vital technique known as shoot and scoot. This mobility made them incredibly difficult targets for the German counter-battery fire that had plagued the earlier, static British guns. The German lines were unprepared for the sheer volume and speed of the fire that the M7 battalions could unleash. The concentrated 105mm high-explosive barrages were incredibly effective at neutralizing German anti-tank gun positions and suppressing entrenched infantry. The Priest often fired in mass, with entire batteries coordinating their salvos onto single, high-priority targets deep behind the front lines. This rapid, coordinated fire became a crucial element of the Eighth Army's fire plan as they prepared for their great breakthrough. The psychological effect on the German troops facing this new, mobile storm of steel was also considerable. They had expected the Allied fire to be slow and predictable, but the M7 shattered this assumption with its swift responsiveness. The success at El Alamein instantly validated the entire concept of the self-propelled howitzer and the M7 specific design. The British were so impressed that they requested even more priests for their campaigns in the Mediterranean theater. The initial reports of the M7's combat performance began to filter back to the German High Command, but the early skepticism persisted. They attributed the M7's success to the overwhelming Allied material superiority rather than the vehicle's inherent design merits. They saw the M7 as simply another piece of the massive American logistical train, not a true tactical innovation. This dismissal meant they still failed to adapt their counterattack doctrines to the threat posed by this new, mobile artillery. The core of the German generals' disdain for the M7 Priest lay in their deeply ingrained, rigid military doctrine. They were trained to value heavily armored, fully enclosed fighting vehicles that could withstand direct tank-to-tank engagements. The open-topped fighting compartment of the M7 was seen as an unforgivable vulnerability that rendered the entire design fatally flawed. In their eyes, any vehicle on the battlefield should be capable of fighting and surviving in the main line of contact. They believed the M7 would be instantly wiped out by a single well-placed shell or even by shrapnel from high-angle fire. This judgment ignored the fact that the Priest was never designed to be a frontline tank but a piece of protected, mobile artillery. Its role was indirect fire support, engaging targets miles away from the main battle, a function where heavy armor was a hindrance, not a necessity. German armor design philosophy was centered on increasing gun caliber and maximizing frontal armor protection. They had their own self-propelled guns, such as the formidable Stu-G assault gun, which was heavily armored but tasked with a fundamentally different role. The Stu-G was a direct-fire, infantry support weapon, a contrast to the Priest's high-angle, indirect fire capability. The Priest's 105mm howitzer was considered by the Germans to be a relatively low-velocity, short-ranged weapon unsuitable for modern armored combat. They mistakenly measured the M7 against their own powerful high-velocity anti-tank guns and found it wanting. The logistics of mass production were also entirely foreign to the German military-industrial complex. Their focus on highly specialized and often over-engineered designs meant their output was always dwarfed by American production numbers. They failed to grasp the strategic value of a simple, reliable, and easily produced vehicle available in overwhelming quantity. The German belief in technical superiority over logistical reality was a constant theme throughout the war, a misjudgment that cost them dearly. They believed that a few superior Tiger tanks could offset the flood of American Shermans and Priests, a mathematical impossibility. Their generals saw a makeshift weapon, but the Allied artillery crews saw a reliable, fast-moving gun platform that gave them a critical edge in every engagement. The arrogance of their doctrine meant they continued to prioritize heavy, costly designs while the Priest quietly proliferated across every front. The true genius of the M7 Priest was its seamless integration into the burgeoning Allied mobility doctrine. Prior to its introduction, any advance required a massive pause while heavy guns were towed, unlimbered, emplaced, and finally zeroed in. This inherent delay allowed a retreating enemy to establish new defensive lines and prepare a coordinated counterattack. The Priest eliminated this pause entirely, allowing infantry and armor to keep their advance moving under a constant umbrella of fire support. A Priest battery could move with the tanks, stop on a dime, receive a fire mission, and commence a devastating barrage within minutes. This responsiveness was a revolutionary shift in battlefield operations, fundamentally changing the pace of the ground war. The vehicle's speed meant it could quickly follow up on a successful assault, keeping pressure on the enemy and preventing them from reorganizing. Conversely, in defense, the M7 Priest could swiftly reposition to avoid return fire, a crucial factor in maintaining the battery's combat effectiveness. The ability to relocate rapidly was particularly vital in the fluid, fast-moving campaigns across North Africa and later in Italy. Its tracks allowed it to traverse difficult terrain, mud, sand, and rough roads, far more effectively than any wheeled or towed artillery piece. This tactical flexibility ensured that the infantry always had immediate, high-explosive fire available to suppress machine gun nests and destroy field fortifications. The mobility of the Priest transformed the division artillery from a slow, deliberate asset into a dynamic, offensive weapon system. Field commanders learned to rely on the M7 to solve small tactical problems that would have previously stalled entire operations. The concept proved so successful that the Priest served as the blueprint for all future Allied self-propelled artillery designs. Its speed and ease of operation created a new expectation for fire support on the modern battlefield. The Priest was a testament to the idea that tactical flexibility and responsiveness could be more critical than massive armor. It was a machine designed to be anywhere and everywhere its firepower was needed, a true workhorse of the combined arms team. This doctrinal shift allowed the Allies to execute continuous operations, putting the German forces under relentless, unceasing pressure. The Allied invasion of Sicily in July 1943, Operation Husky, proved to be another proving ground for the M7 Priest. The mountainous and rugged terrain of the island presented a new and significant challenge to traditional towed artillery. Hauling heavy guns up steep, winding mountain roads and establishing stable firing positions proved to be a logistical nightmare. Once again, the Priest, with its powerful engine and tracked chassis, demonstrated its superior performance in difficult, uneven landscapes. The sheer speed with which the M7S could establish firing positions and lay down a barrage was a shock to the defending German and Italian forces. As German divisions attempted to execute their textbook counterattacks against the Allied beachheads, they ran headlong into an invisible wall of fire. The priests were often dug in just behind the frontline infantry, perfectly positioned to unleash defensive barrages on the charging enemy. The German infantry, conditioned to expect a certain rhythm of battle, were suddenly subjected to an overwhelming volume of 105mm shells. The high-explosive rounds were particularly devastating to massed infantry, turning open ground into killing zones. These barrages broke the momentum of the counterattacks before the German armor could even properly engage the main Allied defensive line. German commanders were baffled by the speed of the Allied response, unable to properly locate and neutralize the mobile M7 batteries. The constant, accurate shellfire caused widespread panic and significant casualties among the German formations. The term shell shock took on a new and literal meaning for the troops who faced the unceasing, mobile artillery of the priest. The priests not only fired indirectly but were occasionally called upon to fire over open sights at advancing tanks in desperation. Though not designed for this role, the 105mm howitzer was capable of surprising and stopping lighter German armor at close range. This unexpected versatility added another layer of defensive capability to the Allied front lines. The success of the priest in Sicily solidified its reputation as a vital and dependable machine across the entire Allied command structure. The German general Scoffing was now being replaced by a grudging and fearful respect for the firepower this humble vehicle could unleash. The priest's most critical and high-volume deployment came during the massive Allied invasion of Normandy in June 1944. The D-Day landings presented the ultimate test for the concept of mobile fire support, requiring instant action upon reaching the beaches. The initial waves of M7 priests rolled off the landing craft and immediately began driving inland, their guns ready to fire within minutes. Their presence was absolutely essential to support the infantry as they struggled to clear the formidable German defenses and push off the beaches. The hedgerow country, known as the Bocage, was a nightmare for advancing armor and infantry, offering perfect defensive positions for the German troops. The high-explosive shells from the priest were the perfect tool for blasting holes in the thick earthen banks and entrenched German positions. The German military doctrine of immediate and aggressive counterattack was fully expected by the Allied planners. As panzer divisions were slowly brought up to the front, they launched powerful, concentrated thrusts to push the Allied forces back into the sea. These counterattacks, meant to be decisive, became a devastating showcase for the M7 priests' defensive capabilities. Massive concentrations of priest artillery were pre-registered onto likely German attack routes, creating pre-planned killing zones. When the German tanks and infantry advanced, they were met not by a line of tanks, but by an overwhelming, deafening rain of 105mm shells. The speed and accuracy of the Allied counterfire effectively shattered the cohesion of the German assault formations. The counterattack stalled, and the German forces, suffering heavy losses in both men and material, were forced to retreat and reorganize. The sheer volume of fire delivered by the M7 priests in Normandy was unprecedented and proved instrumental in securing the beachheads. The steel hammer of the priest repeatedly crushed the German efforts to break the Allied hold on the French coast. The generals in the German command posts could no longer dismiss the M7, its fire was a concrete, terrifying factor in every battle. The tactical success of the M7 Priest was inextricably linked to the highly efficient Allied fire mission control system. The Priest itself was merely the gun platform. The true power lay in the network of communication and coordination that directed its fire. Forward artillery observers, often positioned perilously close to the enemy lines, were the eyes of the artillery. These observers used radios to relay precise targeting information, including range, bearing, and the type of shell needed, back to the firing batteries. The speed of this communication was essential. The faster the data was processed, the sooner the destructive fire could arrive on target. The Priest crews were highly trained in rapid-fire techniques, often managing to deliver a high rate of fire for short, devastating periods. Specialized fire direction centers were established just behind the front, manned by expert mathematicians and technicians. These centers would calculate the necessary elevation and traverse for each M7 in the battery, factoring in wind, temperature, and projectile type. This centralized control ensured that an entire battery of Priests could fire with terrifying accuracy onto a single point miles away. The M7 Priest's reliability meant that the crews could trust the vehicle to perform under the high-stress conditions of an immediate fire mission. The vehicle's simplicity also meant that complex breakdowns were rare, keeping the guns in action and minimizing downtime. When a German counterattack was detected, the response was not a slow, deliberate reaction, but an instantaneous downpour of artillery. This ability to immediately saturate a target area with high explosive fragmentation shells was the key to shattering German morale and formations. The Germans struggled to replicate this level of coordinated, responsive artillery support, relying on slower, less flexible towed guns. The Allied system, of which the Priest was a reliable linchpin, demonstrated the full potential of motorized, indirect fire warfare. The sheer speed of the fire mission cycle gave the Allies a decisive tactical advantage on every front. The most memorable moments of the M7 Priest's career involved its role in definitively crushing German counterattacks. In numerous battles, particularly across the Normandy and Italian fronts, the Priest functioned as the ultimate defensive weapon. A typical scenario involved a rapid German armored thrust, often supported by infantry, attempting to exploit a perceived weak point in the Allied line. As the German forces advanced, the forward observers would call in an emergency defensive fire mission, often using special code words. The Priest batteries, already zeroed in on likely attack corridors, would immediately unleash a coordinated, overwhelming barrage. The resulting firestorm was designed to separate the German infantry from their supporting armor, leaving both vulnerable and disorganized. The high-explosive shrapnel would tear through the light armor of half-tracks and decimate the accompanying German infantry formations. Even the heavy German tanks, such as the Panzer IVs, could be immobilized or damaged by the sheer concussive force of the exploding shells. The sight and sound of dozens of 105 mm shells impacting a small area in quick succession was often enough to cause an entire attacking unit to break and scatter. The German generals had banked on the slow, deliberate nature of the Allied artillery, but the Priest delivered fire faster than they could advance. This rapid intervention prevented small breaches in the line from escalating into major operational setbacks for the Allies. The ability of the Priest to switch from high-angle, long-range fire to direct, open-sight defensive fire provided a crucial measure of last-resort protection. Though dangerous for the crew, this direct fire capability allowed them to engage and defeat enemy armor that managed to break through. The M7 Priest effectively acted as a mobile, unshakable wall of high explosives, shattering the morale and the cohesion of every German counterattack it faced. Its firepower was the silent, crucial component that allowed the Allied infantry to hold ground against superior German armor. The tremendous success of the M7 Priest irrevocably changed the global understanding of artillery's role in modern, mobile warfare. Its wartime performance fully validated the concept of mating a large-caliber gun with a tracked, armored chassis for battlefield mobility. The Priest served as the foundational blueprint upon which almost all subsequent Western self-propelled artillery designs were based. The lessons learned from the M7's combat service directly influenced the design of its successor, the American M37 howitzer motor carriage. The M37 featured an improved chassis and a more powerful 105mm gun, refining the concepts pioneered by the Priest. However, the enduring legacy of the Priest was its influence on the fully enclosed self-propelled guns of the post-war era. The open-top design, while tactically flexible, was eventually replaced by fully armored turrets for better crew protection against chemical and nuclear threats. Vehicles like the American M44 and the M52 were direct descendants, incorporating the self-propelled mobility into a more advanced, turreted system. The British, having used the Priest so effectively, developed their own line of self-propelled artillery, including the Sexton, which was based on the Canadian Ram tank chassis. The Priest's revolutionary impact was less about its specific armor and more about its core mission: highly mobile, responsive, indirect fire support. Modern self-propelled howitzers, such as the American M109 Paladin and the German PZH-2000, owe their very existence to the doctrinal shift initiated by the M7. These modern systems retain the Priest's high mobility but add features like autoloaders, computerized fire control, and superior armor. Even decades later, the tactical requirement remains the same: the artillery must be able to move and fire at the speed of the frontline maneuver force. The German general's initial derision proved short-sighted, as the Priest's fundamental design concept became the global standard for heavy artillery. The humble M7 Priest was not an endpoint but the beginning of a completely new chapter in the history of mobile warfare. The M7 Priest never achieved the iconic status of the Sherman tank or the P-51 Mustang fighter plane, yet its impact was arguably as significant. It was a dependable, unsung workhorse, a machine that performed its vital, dirty job on every major battlefield of the Second World War. The Priest was deployed by the American, British, Canadian, Free French, and even the Commonwealth forces, demonstrating its universal utility. It saw action from the scorching deserts of North Africa to the muddy, frozen forests of the Battle of the Bulge. Its reliability earned the deep respect of the infantrymen it supported, who often credited the Priest's timely fire for saving their lives. When a German assault threatened to overwhelm a position, the M7 Priest was the asset called upon to break the attacks back. The vehicle was a testament to the strength of pragmatic, mass-produced American military equipment. It proved that quantity, when combined with reliable function, could overcome the initial perceived quality of over-engineered, specialized enemy designs. The German general's initial scorn was born of arrogance, an underestimation of a simple design perfectly suited for its specific, critical mission. They saw a flaw in the open top, the Allies saw a tactical advantage in speed and visibility. They saw a converted tank, the Allies saw a highly mobile, dedicated fire support platform. The story of the M7 Priest is a powerful reminder that military history is often shaped by the simple, dependable machines that perform the heavy lifting. Its thunderous barrages crushed the German counterattacks and solidified the Allied ability to advance and hold the line. The Priest was the ultimate validation of the self-propelled artillery concept, a quiet but powerful force that hammered its way to Allied victory. Its enduring legacy is one of silent competence, a true battlefield MVP that earned the fearful respect of the very enemies who had once dismissed it.